Hey everyone, this is Professor Evans, and I'm going to give you a sneak peek into Lab 3, and I'm going to show you what the output of your circuit will look like when you're finished, as well as discuss the process for designing this circuit. So what you see on the screen is the DE10 board, and you'll see that I'm going to be using 4 hex displays. This one is being used, it's just showing a blank character. So you're going to be using 4 hex displays, and you're going to display different characters. And you're creating a multiplexer where when I change the value of my select inputs, in this case my select inputs are going to be switches 9 and 8, I'm going to see the characters on the screen rotate in sort of like a shift left pattern. So that's what's going to happen when you complete the exercise. Now before I show you a video of how this works, I'm going to show you how this is set up. Switches 7 and 6 are currently controlling the output of hex number 3. Depending on the location of these switches, I can display a D, an E, a 1, or a blank character. When the switches are both low, I'll get a D. These 2 switches are controlling the next hex display in line. So when the switches are both low, I'll get a D, but when one switch is low while the other is high, I'll get an E. These 2 switches are controlling this hex display right here, hex 1. When the first switch is high while the second is low, I'll get a 1. Now if I were to change any of these switches around, the characters would also change. So for example, if I took the 2 switches in the red box and I made them look like the switches in the green box, then this first hex display would also be showing a 1. So I'm controlling what's coming out onto the hex display based on 2 select inputs for each hex display. These last 2 inputs control the final hex display, and in this case I'm displaying a blank character, which is going to come from a selection of 1, 1. So the first part of your lab is going to be to design a multiplexer that will display a character based on 2 inputs. So you'll just be working with 1 hex display to start with, and you'll figure out how to display the D, the E, and the 1 on a single hex display by manipulating these 2 switches. Once you get it working for 1 hex display, you're now going to extend this to 4 hex displays. So now I'll show you a video of the final output of your lab, which is from part C. What's going to happen is you're going to set these switches 0 through 6 as I just showed you. You're going to set them to show the D, the E, the 1, and the blank, and then you're going to leave them alone. And you're going to manipulate only switches 9 and 8. So what's going to happen is when I change these switches from 0, 0 to 0, 1, the D that was here rotated to the end, and everything else shifted to the left. I'm going to change the inputs again. Now the inputs are 1, 0. Once again, we see a rotation. The E rotated to the end, and everything else shifted to the left. Change the inputs again to 1, 1. And a final rotation occurs, where now the blank space is first and everything shifts over to the left. So I'll let you see that one more time. Here's the beginning, 0, 0. 0, 1, there's a shift. 1, 0, there's a shift. 1, 1, there's a shift. So you're building a circuit where you're rotating these characters from one hex display to the next as you change these 2 select inputs on switches 9 and 8. So your next question may be, well, how do I do this? If you read through the instructions, it walks you through how to do this by going through 3 parts. Part A is going to begin by instructing you how to use the hex displays. So the hex displays are labeled with 7 segments, 0 through 6. In order to turn a segment on, you have to drive it to a logic value of 0. In order to turn a segment on, you have to drive it to a logic value of 0. So if I want to display the number 1, I need segments 1 and 2 to be on, while all others are off. This is your truth table. So your 2 select inputs are going to dictate what character comes out on the display. These are your 4 character codes. So you're going to start by making a truth table. When C1 is 0 and C0 is 0, which segments of the display should be on and which ones should be off? Figure that out and fill in this row accordingly. Then, as C0 becomes a 1 while C1 is still 0, which segment should be on, which segment should be off? Fill in this row accordingly. Once you have all 4 rows filled in, take each output. We have one output for segment 0 of hex 0. We have one set of outputs for segment 1 of hex 0. There are 7 segments all together. You need to figure out the logic for each one of those 7 segments. And this is how you're going to do it. Truth table first, then you're going to take just the outputs for segment 0, make a K-map, and find an output expression. Take all of the outputs for segment 1, make a K-map, make the output expression. Once you have the output expression, that's your Boolean expression that you're going to program within your architecture. So your architecture is going to have 7 statements, one for each segment of the display, and it's going to be Boolean logic that tells what segment should turn on based off of inputs C1 and C0. Once you get this part working, you're then going to move on to part 2 where you extend it to rotating your 3 characters D, E, and 1 on the displays. You're going to use this by instantiation, which you can read about in pages 58 to 66 of your textbook. In order to implement this idea, you're going to extend what you've done in part A. So part A is going to basically control your individual segments. You're going to set up your circuit so that you have switches 5 and 4 will be set to the letter D. Switches 3 and 2 will be set to display an E. Switches 1 and 0 will be set to display a 1. Then, as I manipulate these 2 selects, it becomes a multiplexer where your output will rotate. So for part B, you're basically going to take your 2 selects and try and get the pattern DE1 to show on the first 3 hex displays. As you change these inputs, the characters should rotate. In order to do this, I've given you some sample code to get you started. It is not complete. It will not compile if you just copy and paste it into Quartus. My advice is that you read through this code line by line. Understand how it works and why it works. Then there are 2 places where you're going to have to fill in your own code. Figure out where those places are, write your own code to complete this sample, compile it, and test it out. Part B will be the longest part. Once you get part B working, part C will be very simple because you just have to extend that part to now include the blank character in your rotation. So as you change the selects to these 4 different options, the characters should rotate according to this table. And that's what you saw in the video that I showed you. Remember to accurately light up the correct segments. So for example, a 1 is going to be lit up by the 2 segments on the right, not the 2 segments on the left. Make sure that when you decide which segments need to be on or off for each character, that you follow this pattern shown in the table. Lastly, all of your code, once you turn it in, is run through a test bench that verifies whether or not it runs properly. Make sure that you are uploading a text file of your code to Canvas with every submission, in addition to including your code in the lab report. If you don't upload a text file of your code, I can't test it. And if I can't test it, then I can't grade it. Make sure you have a text file of your code uploaded to Canvas. Make sure that text file follows all of the directions for your code provided within the directions. If you don't follow all of these directions carefully, your code will fail the test bench, which means ultimately your code may not be given a passing score for this lab assignment. If you have questions as you start the assignment, please email me. If you run into compiler errors that you don't understand, please email me. Also remember that you can go to the Open Lab online and talk with Neil Bishop or Scott Sawyer for help as well. So that's it for Lab 3. Good luck. Start early. This will take longer than Lab 2. And I promise that the more you practice and the more you study, the easier this will become. Good luck. Let me know if you need anything.